class, section 4.3, binomial distribution. All right, this one says a trainer is teaching a dolphin to do tricks. The probability that the dolphin is successful, successfully performs a trick is 35%. The probability that the dolphin does not successfully perform the trick is 65%. Out of 10 attempts, what do you find? Do you want to find the probability that the dolphin succeeds at most 5 times? Okay, just verifying this is a binomial experiment here for part 1 here, number of fixed trials n. In this case, there's the 10 attempts. Is there 2 possible outcomes for each attempt? Absolutely. Here, the success does the trick, and deemed as failure is not the trick. Associated with those probabilities, the probability that the trick is done correctly is stated up here. It says here, probability to perform successfully, 35%. Pouring that into a probability, of course, or a decimal there, 0.35. The probability that the dolphin does not successfully perform the trick is 0.65 or 65%. There, stated. A lot of cases they don't give you the complement. If that's the case, then you just naturally subtract that from 1 to figure out what Q is. Are they independent? We're assuming that they are independent. Nothing is said there in the prompt. There are cases when you're performing, I guess in this case, number tricks, there could be some cases of discouragement and you just eventually just give up. But assuming that the probabilities don't change, make it more simplistic rather than getting too psychological about it. Part 4, the possible value of x, 0 through n there. Okay, so 0 would mean that the dolphin performed none of the tricks correctly, only 1, only 2, or 3, up to 10 performed all 10 tricks. Associated with those probabilities, the dolphin were able to perform all 10 tricks correctly. That would be pretty much impossible to do, and the range of values up to there. Looks like our peak here is at, we'll talk about that, dealing with mathematical expectation. But let me go ahead and set that up. Notice here at the 3 has the most likely probability at 25.22%, so we could expect that out of the 10 attempts that the dolphin again would perform 3, or about 3, maybe in between 3 and 4 tricks correctly. Alright, grabbing here the calculator here, placing it, so the 10's already there from the last problem that we did, and putting in the 35%, 0.35, the probability of P, so here it doesn't ask for Q at all, it does that math for us, and it looks like displayed here is all those probabilities, and here looking at the peak is at 3. That's the top is always associated there with x as our expected value. But nonetheless, they ask for the probability that it is at most, let me go back to that, at most 5 times, that is up to the number 5. And that is displayed with the bracket here, GeoGebra on the left, so that you may want to write that down, some of that language associated with some of these. That at most represents a bracket opening to the left, so I'm going to have to do that here. Grab that and place the number 5 down here below. Enter and click back here. Once you're done entering in the value, just kind of snake through. The last step here is to click on that answer box. And there you go, you got the sum. And what it does is it adds up all those probabilities for us, even displayed here as it's done that. It highlights everything from case 0 up to 5. Tricks done, performed correctly by adding those probabilities for us as displayed here. So basically it takes the probability that none are done correctly, 1 is done correctly, 2, 3, all the way up to 5 tricks are done correctly, and that probability would be 0.9051 or 90.51%. So that will complete it for the Dolphin there. In this problem, it does not ask for the mean, variance, or standard deviation, but nonetheless that could be done using those associated problems.